Think. Yeah. So, yeah. Good morning. Welcome. So this is basically the first webinar in the Wednesday webinar series conducted by Kerala Blockchain Academy. My name is Sethuraman, and I work as a research and development engineer at Kerala Blockchain Academy, and I will be hosting today's webinar. So today's webinar is based on the topic blockchain for beginners. Now, when we say beginners, we don't necessarily mean people who are exclusively from the IT industry. Anybody who is curious about this technology can actually tune into this webinar and get to know this technology. So, before we start, I would like to give a fair amount of warning. So, like I said, this webinar is intended to introduce the basic concepts or the fundamental concepts of this technology. So, we won't be dealing much about the high-end technical aspects of this technology, but we will be dealing with the basic and the most fundamental concepts. Now, like I said, anyone irrespective of their background can tune into this webinar. You don't necessarily need to be uh, someone from the CS background or the IT industry. Anybody who is interested in this technology can actually tune into this webinar. Now, like I said, since this is meant for everyone, I will try to refrain from using technical jargons to explain stuff so that we could keep things simple. So, yeah, and during the course of this webinar, you can actually post your doubts in the live chat. We will be having breaks in between these sessions, and I will address those doubts. So, if you have any doubt, you can actually uh, you know uh, post it in the live chat. So yeah, uh, and if you are already familiar with this technology, consider this whole thing as a refresher. So, with that in mind, let's begin the webinar. So, where do we start? Okay, so I know for a fact that if you are listening to this webinar, you are curious about this technology. You want to know more about this technology. And in fact, I think that most of you might have already tried understanding this technology called blockchain. So, the thing is, whenever you ask someone or whenever you refer about blockchain, you get a combination of these statements. This is what you get. It's basically the combination of what's on the left was what's on the right. So the thing is, it actually depends on the person whom you ask. Like, if you ask a developer regarding what a blockchain is, he will tell you that it is a decentralized distributed digital ledger technology. As a developer, they like their encapsulations and abstractions, so that's what you get from a developer. Now, if if someone says to you that it is a cryptographically linked list of records which is time stamped and which cannot be altered in any way, and that definition leaves you a bit more confused, you're basically talking to a researcher. And if somebody comes to you and tells you that this is this top-notch technology, this amazing technology on top of which you could build these amazing applications that can, help you transfer any and all kinds of digital assets and things like that, well, you are basically talking to someone in the marketing. So the thing is, I'm not saying that each of these definitions are wrong. They are not wrong. They are right. They're, in their own various perspectives, they hold truth in the blockchain sphere. But the thing is, as someone who just entered into this technology, what does each of these statements tell them? Like, what kind of a picture does these statements paint? So, like I said, these statements, they have the full standard structure of a definition. They have big jargons. They are abstract, and they might cause some amount of confusion. So they can pass for a definition. But the thing is, as a beginner, if you hear any of this, you might end up a bit more confused. So during the course of this webinar, what we intend to do is we will break down each of these statements and tell you what it exactly means. So by doing so, we'll be exploring the technology, exploring its fundamental, and I will give the meaning, or I will tell you how all these jargons fit into the blockchain sphere. So that's what we are going to do in today's webinar. So let's get started. Statement number one: blockchain is a decentralized distributed digital ledger technology. Now, the thing about this statement is that, you know, I think this is the most commonly used definition for a blockchain. Like, I have come across this definitions many a times, and that's why I put it in the slide. So, what does this mean? You have words like decentralized, distributed, you have all those words, but what does all these mean? Where does it fit into the technology that is blockchain? So, in order to understand how it all fits in, or how this definition plays in the phase of blockchain, I'll give you an example. So, suppose this is a classroom, okay? Now, this is not like a normal classroom, because here, the most studious kid among the students, he is responsible for taking down the notes. So you have a bunch of kids sitting in a classroom, and the most studious one among them gets to take down the notes. So that is, it means that if any of them, any of his colleagues wants to refer the notes, they have to go to him in order to get the note. So here, the process of taking down the notes is what you call a centralized process. It is centralized. So what does that mean? Centralization. So centralized basically tells you that there is a single authority controlling an operation or a system. Like in this case, that studious kid, the one with the hat, he is responsible, or he is in control of taking down the notes, so that he is a singular authority who has the control over that particular process. Now, I know that this system sounds very exciting, it almost sounds utopian, and we might wonder why we wasted time taking down notes if we had such a system. But the thing is, there are issues with the system. Let's go through some of them. Think about it. So you have one kid taking down the notes for the entirety of the class. Like for everyone, nobody else is taking down any kind of note. He is solely responsible. He is the central figure or centralized authority who is responsible for taking down the notes. Now, what if that kid took a leave of absence? What if he didn't come into the class any given day? So, if such a situation comes in, the entire process of taking down the notes gets disrupted, or it crashes with the kid, because if he is not there, then that means nobody can take down the notes. So now that is scenario number one. Let's talk about another scenario. Suppose, as a prank, someone comes in and corrupts that kid's notebook. What do you think will be the effect? You see, in order to misinform the entire class, all someone have to do, is to corrupt the single notebook of that kid. So if he does that, he can just misinform the entire class. Let's go through another scenario, that is, during exams. Suppose exams are coming up and all the kids, they want to refer to the notes, so what they do is they flock to this studious kid and ask for the notes all at the same time. Suppose, how those situations are. Right before the exam, all of us flock towards the most studious one to clear our doubts. Just like that, they go to this kid to you know get the notes. Do you think he will be able to efficiently distribute or efficiently clear the doubts of each and every kid? So, when you analyze this particular situation, you can understand that the availability and the security of the information in this kid's notebook is in question. Availability in the sense that if the studious kid took a leave of absence, the data or the information is no longer available. Just like that, if all of these kids flock to this studious one for notes, he won't be able to make these notes available to everyone in an efficient manner. So such a system where a centralized authority is responsible for a process, if that centralized authority goes through some errors or something, it affects the availability of the information. Now, talking about the security, like I said, if I have to misinform if I have to spread some gibberish notes to the entire class, all I have to do is to correct that particular kid's notebook. I don't have to do anything else. And since everybody is referring to that singular notebook, all of the class will be misinformed. So these kind of problems, you know, whenever you look at any kind of centralized system such as this one, these kind of problems persist. Now, when you look around, you can see that there are n number of centralized systems like this. Most common being, all of us use WhatsApp, Facebook. All of us went to the university where they had this servers and everything, and all this hospitals, schools, they all have what is known as a centralized database. So what it does is it collects information in a particular central location, that is a centralized database. So if anything is to happen to that particular system, it affects everyone. Now, the scenario when the university publishes its results. All of us flock towards this website in order to see our results. So what we end up doing is we crash the site. So the reason is similar to the situation given here. Too many kids come for the results at the same time, which crashes the system. So when you look at any given centralized system, you can actually compare it to the scenario where one kid is taking down the notes for the entire class. The information is the storage of information is controlled by a central authority, which makes the availability as well as the security of that information in question. So now let's go to another scenario. This is a normal classroom, or the best case scenario of a normal classroom where everybody takes down their own notes. Now, as you can see, here there is no central authority controlling the taking down, the process of taking down the notes. There is no single kid who is responsible for doing it. Everybody does it on their own. So this kind of a situation or this kind of a scenario is called as a decentralized process or a decentralized scenario, which means that there is no central authority who is responsible for or who holds an authority over a process. Just like when we talk about taking down the notes in normal class, all of us are, there is no one who is responsible for, there is no single entity who is responsible for taking down the notes. Each of us are on our own. So basically, when you look at a classroom, you can see that it is, the process of taking down the notes is actually decentralized, since there is no central authority controlling that process. And it is also a distributed one, since everybody shares a copy of a notebook. Everybody has their own notebook and they take down the notes in their own respective notebooks. It is a distributed process, like the intake mechanism is actually distributed. Intake mechanism being the notebook, it's actually distributed among all the students in the class. So you have, when you look at the scenario, you see that you have a decentralized, distributed physical notebook that you use to take down the notes. This is what you get in a normal classroom scenario. Now let's go over those issues that we talked about. What if a single kid from this class takes a leave of absence? Do you think it will affect the process of taking down the notes? Do you think it will affect the availability of the information? You see, everybody is taking down their own notes. A copy of the note is with every single student in the class. So in such a scenario, even if a kid took a leave of absence, the information is still stored among all the rest of the kids. So the next day, if he shows up, he can simply refer to his colleague's notebook and synchronize with the rest of the classroom. Now, what if someone comes and corrupts a notebook? Somebody wants to misinform the whole class regarding some notes, and he corrupts a single notebook from this entire bunch. Do you think that will be effective? You see, when you have a distributed system like this, where everybody shares the notebook and everybody takes down their own notes, sorry, even if a single notebook, even if somebody corrupts a single notebook, it won't affect the rest of the class. And the person whose notebook got corrupted, he can actually rectify his mistake, the mistake in the notes, by just comparing it with his colleagues. So in such a decentralized, distributed scenario, the availability as well as the security actually increases. You can see that, even if someone corrupts a single notebook from this cluster, it doesn't affect, because people can point out the mistakes. Since everybody has the copy of that notes, they can point out the mistakes in those notes, and he can correct his mistakes. So just like that, when you are introducing a decentralized and distributed system, it actually helps by increasing the availability as well as the security of the information. Now, let's talk about the next scenario, which is the exam scenario. Now, since everybody has their own notes, they don't have to clutter to a particular person for asking the notes. They can refer to their own notebook. They don't have to rely on a third party or a trusted authority to get the notes. They have their own notes, so they don't have to rely on someone else. So these are the benefits. So when you look at the normal classroom scenario, you have a decentralized distributed physical notebook that you use to take down the information or the notes that is given by the teacher. So like I said, so if I am to replace all these kids with computing systems, and if I replace all their notebooks with a digital one or a digital ledger, now I am entering the territory of blockchains. You see, blockchain is basically a way to store your data in a decentralized, distributed fashion, just like our notebooks that we use in our classroom. Everybody who is a participant of this particular network gets to hold a copy of the blockchain. There is no single authority controlling the information intake. There is nobody who controls, or no single figure who controls the blockchain. It is a decentralized digital ledger. And like I said, this ledger is distributed among all these computing systems. Just like when we talk about the notebooks, every kid has a copy of, every kid has their own notebooks, just like that. Every system in this particular network contains their own copy of the ledger. So you have a mechanism for taking down information or storing information or data in a decentralized distributed fashion. And all these systems, or they are also known as nodes, we will get to that term in a bit. So these systems that host, this blockchain, that is, which is basically this distributed ledger that all these system holds, and this system, they together makes up what is known as a blockchain network. So when you think about a blockchain network, you can compare it to that of a classroom, where there is, there can be n number of computing systems, and each computing system holds a copy of a distributed decentralized ledger called blockchain. So this is basically what, when you break down that statement that we talked about, this is the basic picture that should come into your mind. you know it is basically a bunch of nodes or computing system that shares a ledger between them. Now, in this figure, when you look at it, there is a slight problem. You see, when you're talking about a classroom scenario, you have a teacher who is the central authority when it comes to giving the information. Like, all of us take down the notes that is given to us by the teacher. So, in that manner, you know, all the notes in a particular classroom, now I'm talking about the best case scenario, all the notebooks will contain the exact same notes. But when you're talking about a network that spans across the globe, you can't put, when you're talking about a decentralized network and distributed network that spans across the globe, you cannot put any kind of centralized figure on that network. So you cannot have a mechanism like that of a teacher who is giving the information that should be, inducted into the ledger. So how does this synchronization of data occurs, or do you need to synchronize data? All these nodes are scattered across the globe. So do you think that these ledgers, do they need to synchronize the data among themselves? The answer is obviously yes. Now I'll tell you why it's important. Suppose, like what is seen here, each ledger holds different data. Suppose this is the situation. Now, in this situation, even if one of this gets corrupted, like, if a hacker or someone just attacked a particular ledger and, altered its data, there is no way of knowing, or there is no way of correcting it, since everybody holds different data as per their own wishes. So you need a mechanism so that all the ledgers, all the copies of the ledgers that is distributed across this network contains the same data. Otherwise, there is no integrity and to this data, and it is prone to attacks. So what a blockchain network does is that it has a mechanism called the consensus mechanism. Okay, so what this means is that all these various nodes in the network, they before they enter a particular data into their blockchain or the digital ledger, the majority of the participants in that particular network has to agree upon that data. Then and only then can they add the data to their own respective ledgers. So a participant, like you can see, suppose a participant in India, like the server that you see here, he cannot add data as per his wishes. Every data that goes into the ledger should be approved by the majority of these people, and once that data is approved, everybody adds that data, that approved or consented data, to their respective ledgers. So this mechanism, which is used to agree upon a single value of truth that gets added to the blockchain, is basically called the consensus mechanism. Now, there are various kinds of consensus algorithms. So when you are talking about consensus, you have to have a webinar on its own because it's such a big topic and there is a lot to cover. So just know that just like you have a teacher in the classroom who gives the single value of truth that you take down in your notes, a blockchain network has a mechanism called the consensus mechanism, which they use to agree upon a single value of truth that they add to their respective ledgers. So that's how they synchronize all the ledgers, even if it is scattered across various geographic locations. Every data will be agreed upon by the majority of participants in the network. Then and only then can it be added to the network. So this is the basic picture of a blockchain network. You have nodes or systems that contains a digital ledger, and this ledger will be shared by all the other nodes or all the other systems in that particular network, and every piece of data that goes into the ledger or this blockchain will be a synchronized ledger that holds information. Now, to recap, so when you hear this statement that blockchain is a decentralized distributed digital ledger technology, what we have to understand is that blockchain in its essence is basically a method to take down information, to store information. And it does so, sorry about that, in a decentralized and distributed fashion, which means that there is no single authority controlling the blockchain. And a copy of this blockchain or this digital ledger exists with every participant in a particular network. So these are the major terms that we went through, like decentralized, which basically means that there is no central authority. Distributed means something that is shared among multiple parties. In our case, it's that digital ledger. A node. So when you are talking about a blockchain network, a node simply refers to a computing system that contains the entire copy of a blockchain. That is what is basically called a node. Now, theoretically, like I have shown in the figure, it can be any kind of computing system. It can be a laptop, it can be a mobile, it can be a computer, it can be anything, it can be servers, etc. Theoretically. But the thing is, since blockchain, you always add data onto the chain and it keeps on getting bigger and bigger, people always use servers to host the nodes. Nodes are basically, these are the kinds of, people seldom use. There are ways to cut short the size and all, but typically when you are setting up a blockchain network, you do it using servers. So, and we talked about the consensus mechanism, which is actually a method using which all the nodes in this blockchain network actually agrees upon a single value of truth before they each everyone adds that value to their particular ledger. So you have a consensus mechanism, you have a distributed ledger, you have a decentralized system, and you have nodes that host these ledgers or digital ledgers or blockchains. So at this point, you have to, if you have any doubts, I will just take a minute to see if anybody is having any doubts. You can post your doubts in the live chat, so I will be addressing it. So if oh, okay. Wait, so okay. Yeah, so I think there is some issue with the text. Oh, sorry. Yeah, so if there is any doubt, so yeah, I think there is a problem with the visibility, it seems. There is a problem with the visibility, it seems. So let me see what I can do. So if you have any doubts regarding what we just discussed, please use the live chat to uh, address those issues. So I'll take a minute. Oh, I think, yeah, there is. Oh, the video frame. Yeah, let me see if I can do something about it. So yeah. So yeah, there is a doubt regarding how does the nodes get synced. Like I said, a node is basically so there is a doubt that someone asked that how do you sync the nodes. Like I said, they use this mechanism. There is a set of algorithms called consensus algorithms. So what they does is, whenever somebody wants to add a particular data to the blockchain, they have to get the consent of every participant in that network. They use various protocols like gossips and all those protocols. I don't want to get into the technical side of it, since non-IT people might be tuning into this webinar. So anyway, how they sync the nodes is that once they are connected as a network, once they are part of a blockchain network, which means that once they share a common blockchain between them, the data that gets added to the blockchain has to go through this consensus mechanism. So what it does is the consensus, usually when you say you need a consent, it means that you need to agree upon something. So when you are talking about the data in a blockchain, every node has to agree upon a data uh, that gets added to the chain. Now, yeah, how is programming done in blockchain? Yeah, we will get to that part. We will get to that part. So basically, and yeah, yeah, okay. So yeah, like I said, theoretically you can add any kind of devices onto a blockchain network, and it's basically like any other network. You have your own configurations. You have your own configurations or mechanisms so that you can participate in that network. Yeah, like I said, theoretically it can be any devices, but since a blockchain, like I said, it's a digital ledger that keeps on increasing, there can be you know size constraints, or the scalability can be an issue. So what they do is they typically use some kind of servers or something to host that network. They don't usually use mobiles or laptops for hosting a blockchain or hosting a node. Theoretically it can be any computing device, but when it comes to practice they usually use the servers. Okay, in a decentralized system, yeah, who determines which all nodes can, yeah, if so, Yeah, in a decentralized system, who determines which all nodes can participate in the system? Yeah, okay. So think about it, like if somebody is granting access to, there is, mechanisms for gaining access to this decentralized network, but if somebody is actually responsible for it, then that makes it, if you create a central access to it, which goes against the concept of decentralization. We'll talk about how people get into a blockchain network in the coming sessions. For now, just we'll stick on with the definition that, you have a bunch of nodes who share a ledger between them, and the data that goes into these ledgers are synchronized using the consensus algorithms or the consensus mechanism. Like I said, all these concepts, like the how do you program and how do you create a network and how do you access this network and the consensus mechanisms, they are technical aspects of this blockchain. So, if I am to dive deep into this technical aspects, like I said, this is a blockchain for beginners. So if people are not of this technical background, they won't be able to follow. That's why I'm not diving deep into this session. We will have subsequent webinars that deals with all of these particular doubts that you have. Right now, just understand that you have a set of nodes who is part of a network, and all these nodes have a synchronized digital ledger called blockchain, and all the data that goes into the chain is agreed upon by the majority of the network. Only then can this data be added to the chain. I'll show you a demo of how things work in the coming sessions. So that is the first statement. Now, moving on to statement number two. In the statement, blockchain, like I said, this might be someone from the research side. Blockchain is a list of cryptographically linked immutable and timestamp records. So in order to understand the meaning of this statement, there are a lot of confusing terms, like, how do you link blocks, or what causes the immutability, or what is stored, or how data is stored in blockchain. So in order to analyze this statement, you have to understand the structure of a blockchain. Now, we were talking about classes and notebooks. So let's compare a blockchain to that of a notebook. So, like I said, a notebook in a class is also a decentralized distributed physical entity, and a blockchain is a decentralized distributed digital entity. So we'll just compare and see how it goes. So in a notebook, you can see that the notes are always written in its pages. So just like that, in a blockchain, the data is stored in structures called the block. Okay, so you have structures called the block, which is a fundamental structure in a blockchain. So you have blocks where you store the data. Now, when you look at a notebook, here again, I'm talking about the best case scenario. In a normal good class, show you how it works in a bit. So right now, just understand that each block in a blockchain is connected to its previous block. Now, when you look at a normal notebook, you can see structures called blocks, and you create the previous one using crypto, cryptographic links, and we'll see how this link works. Now, this is a typical structure of a block. As you can see, it contains two parts. There is the block body, and then there is the block header. So the block body is where you actually put the data, or the records of the data. Now the block header basically contains information regarding the block. If you are familiar with HTTP, you have a similar structure there too. Now you have an HTTP header and you have the body. Body is where you put the information, header stores the data about a particular page. So just like that, this structure in a blockchain, this block contains a block body that actually holds the data, and it contains a block header which contains information regarding that particular block. Okay, now what goes in. So, there are many kinds of blockchains out there. There are various platforms, but so the data given here is the most general information that is stored in almost all blockchain, in almost all cases. So in a block header, there will typically be something called as an index number. Okay, now the index number is basically like the page number that you put in the page. It basically tells you the number of that particular block, or it tells you the height of that block in that blockchain. Then you have the timestamp, which tells you when that particular block was created. And you have something called as a nonce number, which is basically a unique number that is associated with a particular block. There are technical reasons for adding a nonce number into it, but I think that's a thing for another session. So just know that the nonce number is basically a unique identity or unique number that is attributed to each block. Now you have something called as a hash. Before we talk about hash, you know in order to identify, what do we do when we normally need to uniquely identify a person, like somebody in your office or somebody in your class or somewhere. If you want to uniquely identify a particular person, how do you do it? You see, you either use technology. Mostly what you do is you use the biometrics like the fingerprint or the iris scan. So what it does is, all this produces information. There's fingerprints or there's iris scan or all these things. They produce information that is unique to a particular person. Okay, but how do you do that with a particular piece of data? How do I uniquely identify a particular piece of information? That's where the hash comes in. Now I'll give you, I think it's better to show the demo of how the hash works. Now, yeah, so there is this site. This is quite a useful site because it gives you the demos of most of the concepts that we talked about. Just go to Google and type blockchain demos, and this is the first site that will appear in that list. So you can check out this site. It is pretty awesome, and it will you will get a hands-on experience regarding blockchains. So what is a hash? See, the hash algorithm or the hash function is basically a mathematical function that helps you produce a unique value for a particular piece of data. Okay, it produces, just like we have our fingerprints, the hash function produces something called as a hash value that helps you identify a particular piece of information. I'll show you how. Now you can see that this is the hash value, and we are using an algorithm called SHA-256, which is, I think, the most commonly used hashing algorithm and out there. So if I enter some data, you can see that this data is attributed to a unique value, and this value is called a hash value. So in order to uniquely identify this data, I can use its hash value. Now there are a couple of interesting facts about this hash function. Think about it. uh, you know the thing is, you cannot recreate this data from this hash value. It is what you call a one-way function. You cannot recreate the value or the data from its given hash value. Now, another property of this hash function is that even if I take the entire Wikipedia page of the blog containing the blockchain definition and give that as the data, it will always produce the hash value of the same length. No matter the size of the data, the hashing function always produces a hash value of a particular length. Since we are using a SHA-256, it is a 64 character long hash, which means it has 256 bits. So, like I said, even if I gave an entire book as a data or just a letter, it produces the hash of the same length. Okay, now suppose I gave a bit of data, and the thing is, the slightest bit of alteration to that data, like if I changed my name from this to this, or if I change the caps or something, the entire hash value changes. It will almost become unrecognizable. You can see this hash is entirely different from this one. So even if there is a minute change to a particular information, it reflects drastically in the hash value. So in this block is that you know in order to create the hash in this blockchain, and the metadata, everything, and they hash it to produce a block, passes its hash value to the next block. That's how the previous hash uh, comes in. Like if I'm talking about the index 1234, so what it does is it hashes all these data, like the entire data will be the previous hash of this one. So what does this mean, or what benefit does it give to the blockchain? I'll show you. Like thing. Yeah. So this is a blockchain of length. Yeah, there is I think 6 or something. Yeah, there are 5 blocks. We talked about hash values and everything. So the first block, yeah, you can see that not every block will have a previous hash. Think about the first block in a blockchain, it won't have a previous hash. So how does it form? So the first block in a blockchain is basically called the genesis block, and you usually attribute a bunch of zeros as its previous hash. Since there is no block before the first block, theoretically it won't have a previous hash, but what they do is they put a bunch of zeros as its previous hash. That is the general method. So like I said, each block, you can see here that the hash of this block right here, the block number 1, is actually the previous hash of this one. So what is the benefit of using this hash functions? So this is how you actually link a block to its previous one. This you use this hashing function to create this hash value, and you pass it on to the next block, thereby creating a cryptographic link between the blocks. Now what purpose does it serve? Like I said, the hash is unique to a particular piece of information. So if I am to add or alter any information, what happens is that the previous hash that we passed before, it becomes invalidated, and it invalidates all the rest of the blocks. Like, so in order for me to like I said, if no data is given here, the previous hash of this particular block is valid. But if I alter this data, the entire block becomes invalid, and you have to recreate. Even if you recreate this block which contains this hash, all the rest of the blocks will get invalidated because the previous hash doesn't hold true. So basically, if you put a piece of information onto a block and you hash it and you pass that hash value to the next block, you cannot alter the data that you give, because if you do that, it can be detected and it will invalidate all the coming blocks. So in order for me to alter a piece of information in a blockchain, suppose this is another blockchain, with five blocks, and I want to sort of alter some data in this particular block. So what I do is, I add my data, I add some data into it. So like I said, when you alter the data, it invalidates the block, since the hash doesn't the previous hash of block number 4 doesn't hold true anymore. So even if so in order to successfully alter a data into in a blockchain, what you have to do is you have to recreate all the blocks starting from the one that you have altered till the end of the chain. Like, if I have to alter this chain of length 5 and I alter some data in chain 3, I have to create new blocks till 5. It is taking a bit of time. So basically, when this happens, like, you have to, in order for this attack to be successful, let me just reload it. Think there's some issues with it. Yeah, I think we are back on track. So in order for me to successfully alter some data in a particular chain, like I said, I have to alter all the blocks starting from block 3 till the end, or till the new block. Now, so the thing is, even if you alter a single blockchain from a single peer, it doesn't hold much effect, because like we talked about in the previous session, blockchain is basically distributed. So if you have somebody alters a particular blockchain in a particular peer, it won't affect the network, or this alteration can be identified, since there are other peers who shares the data. Now you can see that if you compare the block number 3, you can see that the hash and all this information of this particular blockchain in this particular peer, the hash is given as 0000CB. But when you look at the next block, you can see that the data is different. So the majority of the blocks hold different data to the one that you have altered. So altering a blockchain, thanks to the consensus mechanisms that you use to create and to add the blocks, the in order to create, or in order to submit a new block for consensus, it is actually a time consuming, and it is actually, there are algorithms that takes time for it, and there are algorithms that take a lot of computational power to create new blocks. So the thing is, once you enter a piece of information onto the blockchain, and once you take the hash and once you pass the hash to the next block, that data would becomes immutable. You cannot alter the data, since like I said, even if you somehow manage, you somehow manage to alter the particular a particular uh, a blockchain, it won't have any effect. Suppose it is a network of 100 nodes that holds a copy of that holds a copy of that ledger. That means you have 100 ledgers. So even if you change one of those ledgers, or if you somehow altered one of those ledgers, it won't hold any effect because the majority holds different data, so they will be able to identify that the particular chain or your particular chain is corrupted. So this is how you basically link each block to the previous one. You take the hash of a block. So this block is linked to, the block number 1235 is linked to 1234 thanks to the hash, because it stores the hash of its previous block. That's how it creates the cryptographic link between the blocks. And if you try to alter the data in any of the given blocks, it will reflect and it will invalidate the next blocks, the coming blocks. So in essence, once you store the data in a block in a blockchain, it becomes immutable. You cannot change it since it is distributed and it has this cryptographic process holding the integrity of the data. You cannot alter the data. So now, like I said, so the information that goes into the ledger is, we talked about consensus and how it consents a piece of information. This block is usually consented. So whenever you are talking about the data that goes into the chain, it is basically the blocks. So everybody in that particular network has to agree upon a particular block so as to add it to their own ledgers. So you have a block where you store data. You use mathematical function called a hash that is used to link blockchains, and once you did that, altering the data in a blockchain almost becomes impossible. So to recap, when you say that blockchain is a list of cryptographically linked immutable timestamp record, what it means is that it uses mathematical function called hash to share or to create that cryptographic chain or that cryptographic link between those blocks. And once you pass the hash to the next block, if you alter the data in the block, it invalidates the hash that you passed on. So it invalidates the entire block. So in order for an attack to be successful, you have to recreate all the blocks from the block that you altered till the latest block. And you have to do it in n number of systems that are part of the network. So that's what makes the data in the blockchain, immutable. So to recap, we looked at what a block is. A block is basically a structure in a blockchain where the data is stored. A block has two parts, which is basically the block header, which stores the metadata or the information regarding certain informations regarding the block and certain other informations. And you have a block body, that is where the actual data is contained. And you have a hash function, which is a mathematical function that produces a unique value for a piece of data. So you pass on these hash values, or a block will contain the hash of its previous block. So if a data is altered in its previous block, it will validate the hash that is passed on. So a genesis block is the first block in the blockchain, and usually the previous hash, this previous hash field is usually set to 0 in a genesis block. So that is, I think, we discussed about. So when you hear the statement, in order to understand the statement, you have to understand the structure of this blockchain. So these are the basic components, and this is how you basically link a block to its next or its previous one using this hash functions. So, and thanks to these hash functions, the data that is kept in a blockchain actually becomes immutable. So, yeah, if you have doubts, now you can ask. So, if there is any doubts, I think. Yeah, I see a lot of questions like, does all the nodes have the same data? And, sir, any other plans for Indy and all those things? See, so I begin this webinar by telling you that we won't be getting much technical about blockchains, since, this is a beginner session and we want to, we have to understand that there might be people here who might not be from an IT background or something like that. So you have to take that into consideration. That's why I'm not going into the whole technical aspects. We are just sticking with the fundamentals of blockchains. You can take an entire session about hashing and consensus and different types of blockchains. You can take an entire webinar regarding all these topics. But the aim of this particular webinar is to introduce blockchain to beginners, and I mean absolute beginners. That's why I'm not diving deep into its technical aspects and things like hyperledger or any other kinds of blockchain platforms. We will just stick with the basics on this one. We will have subsequent webinars that talk about these technical details and all these doubts of how to program. There is a question, how is programming done in blockchain? Yeah, all this requires a basic introduction to blockchain. In order to understand the programming mechanism, you need to understand what blockchain is. So that is what this webinar is for. So yeah, I think if you have any doubts, you can ask. Otherwise, we'll just yeah. Okay then. So moving on. Now, the next statement, or statement number 3, states that blockchain is a technology on top of which you can build application that lets you track and transfer digital assets without the help of third parties. Okay, this is the big one. Everybody wants to know how they develop applications on top of blockchain. So I won't be diving into the developing part. I'll just stick with the basic concept that you need to understand before you step into the developer role. So in order to understand the statement, you have to know what kind of data actually goes into the blockchain. See, typically, blockchain lets you store transactional data or records regarding a digital asset. So, in order to grasp what I meant, we have to talk about Bitcoins. You see, there is no, you cannot skip Bitcoin when you are introducing blockchain. You just cannot skip Bitcoin. And I think most of you might have heard of this. So if you are completely oblivious to Bitcoin, let me give you a slight introduction. So Bitcoin is basically a digital currency. Okay, it is a form of currency. It's a digital currency, which means that it is not tangible. You don't have a physical Bitcoin. It exists as a piece of code in your computer or systems. So what sets Bitcoin apart is the fact that Bitcoin, in order to, in the case of Bitcoin, there is no central bank or any kind of governing authorities that governs the generation or valuation of bitcoins. Okay, so when you talk about bitcoins, you won't see a bank or you won't see a government say generating or evaluating a bitcoin. It is a completely decentralized digital currency which doesn't use banks or any kind of governing authority. So basically it's a new kind of currency. It's a digital currency. So like I said, when you're considering normal everyday transaction that you do with cash, you see that you can actually do a peer-to-peer transaction. Suppose Bob wants to pay cash to Alice, he can directly go and or he can directly go to Alice and pay him the cash. But you know we have institutions called banks that actually helps us deal with the asset, that is cash. So what banks does is they play the role of a trusted third party. We have our asset, cash is an asset, most of us consider that as an asset. So we have banks whom we trust with that asset. So basically the banks acts as a trusted third party. So if I am conducting a big transaction with Alice, if Bob is conducting a transaction with Alice, instead of peer-to-peer transactions, like just going to Alice, to where Alice is and paying her the cash, what we do is we trust the bank to do the payment for us. We give the account details and bank does the transfer for us. So there, banks act as a trusted third party in our normal scenario where we use cash. And you have the government, who is the central authority. You have federal governments who are the central authority in controlling the generation as well as the valuation of cash. Bitcoin is completely different from any of this current systems. It doesn't have a governing authority. It doesn't have a bank uh, using which you can transfer Bitcoin. Basically, it's a peer-to-peer network where you transfer Bitcoin in a direct peer-to-peer manner. So, in order to completely understand why all this came in, you have to understand the story. You see, Bitcoin was introduced, or the concept of Bitcoin was introduced in 2008. And you know what was going on in 2008? The world was going through something called as the Great Recession. So during that time, what happened was there was mismanagement from the part of banks as well as government authorities. So what happened was that due to the failure, many people lost their money, homes, jobs. You know what happened during the Great Recession. So in 2008, an unknown identity by the name of Satoshi Nakamoto, he introduced a new concept, a new kind of electronic cash that doesn't require a bank or a central authority. So in 2008, he published a document called Bitcoin, a peer-to-peer electronic cash system, which introduced the concept of Bitcoins. And in 2009, the first he launched or he started the Bitcoin network. And the first real world transaction, real world purchase using Bitcoin was done in 2010 when this guy, I don't know if I will get the pronunciation right, well, this guy basically bought two pizzas for around 10,000 BTC or Bitcoin. And a decade later, you see that this network of this decentralized peer-to-peer electronic cash, this network that manages its transfer, the Bitcoin network, it grew to such an extent that the network started consuming the energy of an entire nation. In this case, I think we're talking about this is a bit outdated. Like I think it is using more energy right now. Anyway, it reached in 2009. It reached a point where it was consuming half, I think, the energy consumption of an entire country. So in 2008, the world was introduced to this new kind of currency called digital currency called Bitcoin. It is also known as a cryptocurrency. So where does blockchain comes into the picture? Where does why are we talking about Bitcoin when we are talking about blockchain? You see, Bitcoin is the first use case or the first let's just stick with use case of blockchain. So the reason why in order to understand why we needed blockchain in order to introduce Bitcoin, see, Bitcoin is not the only place where we conduct these kind of digital transactions. Whenever you do any kind of shopping in e-commerce websites, any kind of e-commerce website, you basically if you are paying using your debit or credit cards, you are basically conducting a digital transaction, just like when you are transferring Bitcoin, you conduct a digital transaction. So, with the problem with digital entities is that they can be replicated. Okay, they can be replicated. Like for example, if I want to copy a piece of an image or a document from my computer, if I want to share a document from my computer, a PDF file or something, from my computer to my friend's computer, see, I won't approve that whole document from my computer and replanted it in his. What I do is I create a digital copy of that particular digital document and I share one copy with my friend. That's what I usually, that's what all of us usually do. So that in and itself is a problem. You see, when if an entity is of this digital nature, the problem is that it is always prone to replications. That means you can create multiple copies of the same thing. It holds for digital transactions also. So, when you're talking about digital transactions, if somebody is able to replicate that, what ends up happening is that I get to respend, or I get to respend the all an already spent item. So this problem where one person basically respends an already spent cash or currency or something, this is what is called as a double spending problem. So like I said, I can replicate, if things are of digital nature, I can basically replicate it. And if I replicate a transaction, I will be able to respend that transaction, or I can be able to redo that transaction, which, if you think about it, is not good when it comes to any kind of digital currency. So, so this problem of double spending, like I said, it persists with every digital transactions. But when you do a normal, transaction from your e-commerce websites, the thing is you have banks who validate those transactions. You have central banks who are there to validate those transactions. They look at the transaction and make sure that it doesn't fail, or it isn't altered in any ways. So you have trusted third parties that looks out for you in the case of normal scenario. But we talked about Bitcoin and we told that you don't have a concept of bank, you don't have a trusted third party or any kind of central authorities when you're talking about Bitcoin. How do you identify if the transaction is already spent? That's where blockchain comes in. You see, in Bitcoin, what they do is they take this digital ledger and they record all the transactions or all the details of that transaction that happened in that network. Now, I'm talking about the very first transaction, from the very first transaction, like, it was done by Satoshi himself. So, all the transfer or all the transactions done within the Bitcoin network gets recorded in this blockchain. You can actually find the Bitcoin blockchain in the internet. I think it is around some 300 or 350 GB or something. I'm not sure, but it is there. You can download it. So if you look at that ledger, if you look at that blockchain, you can see that every single transaction, the details or the data regarding every single transaction of Bitcoin is actually added to that blockchain using blocks. So if a Bitcoin transaction and this blockchain, like I said, when you talk about the nature of blockchains, you know that it is shared among all the participants. So every node in this Bitcoin network carries a copy of this blockchain, which contains the details of all the transactions in that is conducted in that Bitcoin network. So when you know a transaction comes in, since I have the list of all the transactions that came before this current transaction, I mean from the very first to the very last, I don't have to rely on a bank to validate that transaction. What I can do is I can simply query this ledger to see if the coin that I just got transferred with is already spent. So blockchain basically holds the records of all the transactions. Blockchain was introduced as a method to hold the real-time transaction details of Bitcoin, so that it can be truly decentralized, and it doesn't need to use a third party like a bank or someone to validate the transaction. If a person has, or if a node possesses the blockchain, the entire blockchain, he can basically query the Bitcoin blockchain to see if the Bitcoin is already spent, or if it is already transferred or something. So basically, blockchain solved the double spending problem of Bitcoin. So Bitcoin, the one of the most interesting facts about Bitcoin is that it is one of the first digital currencies to actually solve the problem of double spending, like the digital asset replication or double spending, and blockchain was the facilitator that helped it solve this double spending problem. So from those days, blockchain was actually used as a medium of recording this transactional data. So that's how blockchain was introduced and how Satoshi Nakamoto built a coin on top of cryptocurrency on top of blockchain in such a way that it doesn't need a bank, or it doesn't have a centralized authority to do so. Now, I know there might be, you might be wondering how Bitcoin is created, or how the blocks are added, how many transactions are there in a block. Like I said, we will have sessions detailing all those details. For now, just understand that blockchain was introduced as a technology, or as a record keeping mechanism, or as a decentralized distributed record keeping mechanism, which stores all the transactional details that was done using Bitcoin in that particular network, so that it doesn't have to rely upon a particular bank, or it doesn't have any kind of centralized authority controlling the network. So, like I said, Bitcoin can be considered as a digital asset. Since it's a currency, it's a digital currency, and it holds value. It is a digital asset. So the thing is, why do you limit blockchains to these kind of cryptocurrencies? What if you can do similar transaction with any and all kinds of digital assets? Like Bitcoin was a digital currency, so it's a digital asset, and we use the blockchain to conduct decentralized transactions using the digital asset thanks to the blockchain. So can we do that with other digital assets? Suppose my digital identity, or like digital some kind of digital documents or confidential information. See, why just limit blockchain to particular cryptocurrencies? So this person called Vitalik Buterin, you might be familiar with him. He is basically the creator of another blockchain platform, cryptocurrency, or a blockchain platform called Ethereum. And Ethereum deals with another cryptocurrency called Ether. Just like the Bitcoin network has its Bitcoin, the Ethereum network has its own cryptocurrency called Ether. So the speciality of the Ethereum network is that it sort of created this concept of programmable blockchains. Okay, so what Vitalik Buterin did is he introduced the concept of smart contracts onto blockchains. So, don't get confused. See, smart contracts is not actually the brainchild of Vitalik Buterin. It is an age-old technology. People have been exploring the concept of smart contracts since the early 1980s. Vitalik Buterin, basically introduced that concept onto blockchain. So, what does this mean? I have thrown a couple of jargons like smart contracts and programmable blockchains and Ethereum and all that. So, what does this all mean? Now, when you think about a contract is basically a set of rules. Okay, whenever you hear contract, just imagine a set of rules. Okay, it's that simple. Contract means a set of rules. Now, the thing is, every action that is of a transactional nature will have a contract that governs that action. Okay, I will explain it. Just for now, just you know, understand the statement. Every action of of a transactional nature is governed by a contract, and that contract may or may not be documented. It can be documented, it can be non-verbal, but the thing is, if you are conducting an action that is of a transactional nature, you have a contract governing it. I'll give you an example. Suppose, you know there is a shopkeeper. This is your normal, everyday normal shopkeeper. I went and bought a packet of biscuits from the shopkeeper. Now, that action is of a transactional nature, since I'm transacting money and I'm buying biscuits or something like that, so it is a transactional nature. The thing is, even that action, which is as simple as buying a biscuit, it contains a set of rules, or it is governed by a contract. You know that there are certain regulations that have to be followed in order to conduct such a transaction. The amount of money that I give should be authentic. He should give me something in return that is worth the value that I you know uh, what the value that I gave him. So there are such rules that governs this transaction. So that's why I said that every action of a transactional nature has some sort of contract governing it. So you have your shopkeeper. So when you analyze the situation, you can see that the shopkeeper is basically a third party who makes sure that the contract or this transaction holds the contract. Okay, he is there to validate the contract that we just talked about. So he, once he sees that everything is okay, he gives me the packet of biscuits. So that's what he does. So in this scenario, you can see that I can if you remove the shopkeeper, I can just directly go and take this whatever I want. I can just put a money in the box. But you have you have a shopkeeper who is there to validate the contract and help initiate the transaction. Now, so basically, he is acting as your third party in order to conduct this transaction. You do this, you buy a packet of biscuits using the with the help of the shopkeeper. Now, what if I replace that shopkeeper with a vending machine? What I'm basically doing is I'm basically taking up some hardwares and softwares, and I'm creating a mechanized version of this contract. Even with the vending machine, it holds font from the vending machine. Basically, a computer program where you have given a certain set of conditions. The speciality of this smart contract is that the smart contract is able to verify these conditions on its own. It doesn't require a third party. Like, we talked about how, the shopkeeper is responsible for validating the conditions in this particular transaction, or the conditions in the contract of this given transaction of the shopkeeper. But when you talk about smart contract, you have a computer program where you can give a set of conditions, and that program can itself verify or validate those conditions. And if the conditions are valid, or if you give information that validates the conditions, the smart contract can itself perform the duties of that contract. You don't need to rely on a third party like that, like that of a shopkeeper. You have a contract, or you have a computer program that checks to see if a set of condition holds true for a transaction, and if it does, the contract will itself perform the actions involved in order to conduct that transaction. So that is basically what a smart contract is, a self-validating contract. Okay, so what Buterin did is he introduced this concept on top of a blockchain, and he created the Ethereum network. So now think about it. So up till the point of Ethereum, you basically used, you know, bitcoins to deal with digital assets called cryptocurrencies. You use bitcoins, and there are lots of other stuffs like there are lots of other coins that came in. So that was the only digital asset that you could transfer using, that you can uh, you know handle using blockchains. So with the coming of smart contracts, the thing is, just like you put coins in a vending machine and get the desired items, with smart contract, what you have to do is you have to provide the necessary information or data that validates the conditions in that smart contract. Then, without the help of a third party, it will enforce the necessary action required for the transfer. The way we replace the vendor or the shopkeeper with a vending machine. Similarly, if I provide enough data to the smart contract in such a way that it validates the condition that I programmed into the smart contract, it is able to validate those conditions, and it will be able to enforce the necessary actions without the help of a third party. Now, so what this whole scenario did is it widened the scope of blockchains. Like I said, till then it was dealing with the digital asset called cryptocurrencies, like you have the bitcoins. But now I can, you know, basically transfer any and all kinds of digital assets without the help of a third party using a smart contract. And I can, there won't be replications or double spending problems with that digital asset, since I am using a blockchain to record the details or the transactional details. So you have a smart contract which allows you to program on top of blockchains, and you have the blockchain which keeps the record of all those transactions. So even if you are doing any and all kinds of digital transaction using digital assets, you don't have to rely on a third party. Just think of a scenario where you are buying a piece of land, or you are registering a vehicle. In a normal scenario, the number of third parties that are involved in that particular scenario. Now I can take basically all these registrars and all these official bureaucratic officials. They are there to make sure that we abide by the contract that exists in that transaction when we are transferring a land or a car or something. So if I could take all the conditions that they validate and put it in a program and make it validate itself, I get a smart contract. So basically what it means is that if I could create a digital representation of any given physical entity like that of a land or a car, I can use a smart contract and blockchain to conduct the digital transaction. So the transaction will be initiated by the smart contract without the help of a third party, and the digital asset will be stored, or the transaction regarding the digital asset will be stored in this decentralized distributed ledger called blockchains, so that there is no replication of assets, and the data doesn't get altered. You might have heard of scenarios where people alter the data, normal situations where people alter the data regarding a transaction in order to escape from certain conditions. So with blockchains, you have a trusted ledger that helps you store all this information in a decentralized, distributed, and immutable ledger, and you have smart contracts working on top of it that helps you conduct transactions using digital assets without the help of third parties. So when you hear the statement blockchain is a technology on top of which you can build applications that lets you track and transfer digital assets without the help of third parties, basically what it means is that blockchain allows you to write programs or computer protocols called smart contracts, which basically holds a set of conditions, and these conditions will be validated by the smart contract itself. It doesn't need to rely upon a set of third parties. Now, the applications that you build on top of blockchains are known as decentralized applications, or DApps. Now, I think this vending machine analogy. I got it from Blockgeek. You might have heard of a community called Blockgeeks, which is run by Dmitry Buterin, who is, was just founded by Dmitry Buterin, who is the father of Vitalik Buterin. So, this is the perfect, the vending machine analogy is the perfect one to capture the idea of a smart contract. So, that's it. So when you talk about when somebody tells you that you can build decentralized applications on top of blockchains or applications on top of blockchain, what they are referring to is that you can write complex programs in the name of smart contracts, which lets you conduct transactions by abiding to a protocol that the smart contract can itself validate. Not a protocol, what I meant is contract. So yeah, that's it. So those are the three statements. Now I think there's a couple of slides left. After that, we'll go to the Q&A session. So yeah, some additional information. See, there are ways, or you need, in order to apply a smart contract on top of a blockchain network, there are various there are methods involved. You can't just simply go and write a program in your computer and hope that everybody follows that program. There are ways, there are procedures for doing it. Like I said, we will have extensive sections on smart contract programming and all those in the coming weeks. But for now, just know that you can write computer programs called smart contracts, and you can run it on top of blockchains. So when you look at blockchains, when you look at the timeline of blockchain, you can see that it went through various phases. Just like when you talk about internet, that there is web 1.0, 2.0, and 3.0, and there are various versions. Just like that, when you look at blockchains, you can see that there are various versions involved. The first one was the very first blockchain that was introduced with the Bitcoin network, which was basically a distributed ledger that is used to record transactions done using that cryptocurrency. Next, and that particular phase was called blockchain 1.0. That particular blockchain, that phase of blockchain was called blockchain 1.0. Next, when smart contract was introduced, a new kind of blockchain, so the programmable blockchain, came into picture. So that basically led to the creation of blockchain 2.0. And when you can perform all these kinds of complex programs on top of blockchain, there was mainstream adoption from the part of the industry, and they started building complex decentralized applications on top of blockchains using these smart contracts. And that's what led to the rise of decentralized application. And we, I think, are currently going through the phase of decentralized applications where people are using blockchain to build complex applications. So a couple of things. You might wonder why this guy didn't go with the Bitcoin network itself. You have a network that has a blockchain that deals with a digital asset like Bitcoin. Why didn't he just use that network for creating his programmable blockchain? The thing is, Bitcoin, that Bitcoin network is basically custom tailored to handle Bitcoin. It cannot perform complex operations. It is basically used, and it can only be used. There are some programmable aspects to it, but the thing is, you cannot use the Bitcoin blockchain to perform, uh, you know, complex processes. It is not, as Vitalik Buterin puts it, it is not Turing complete. So, that's why he built his own version of a different blockchain network called the Ethereum network, where you can, sort of create and build applications and complex applications. Now, so when there was a mainstream industry adoption in with blockchains, various kinds of blockchains started popping up. Like when we talked about bitcoins and even with Ethereum, I told you that this data regarding all this transfer of currencies, this cryptocurrencies, those assets, their native assets, the details regarding that asset is basically transfer is recorded in the blockchain, and this blockchain gets transfer the copy of the blockchain exists with every node in that particular network. But when industry adoptions happened, they cannot make all the information regarding a digital asset transfer public. They cannot, there have to be confidential data that should be put into the chain. So when there was this mainstream adoption of blockchain, various versions of blockchain started popping up. The thing is, a blockchain. So basically, you can classify it. There are various well, varieties, but in the when you put an eagle eye view on this thing, you can see that there are basically public blockchains and private blockchains. So public blockchains is basically a blockchain where everybody can see, the general public or anybody who's participating in that network can see all the data and in the blockchain. Whereas a private is a bit more restricted blockchain where you can't simply access that network, or you can't simply view that data in that blockchain networks. So when you think about public blockchain network, think about Bitcoins and Ethereum. And if you're talking about private blockchains, then there is something called Hyperledger thing. Some of you might be familiar with it. If not, if those are not familiar, just explore what is Hyperledger. There are various frameworks in Hyperledger that helps you create private blockchains. So yeah, that is the overview regarding the timeline of blockchains as a technology. So I think we are at the very end of this webinar. Like I said, this is intended for absolute beginners. We only talked about the basic fundamentals regarding blockchains. I think these are the things that most people associate with blockchain. These are the words that you hear, common words that you hear when you say blockchain. I think we have covered all of these topics. So if you have any doubts regarding any of those topics. Now, we talked about how blockchain is distributed. We talked about how it is a decentralized, where it doesn't have a centralized authority. We talked about the blocks and how the chain comes and how it uses cryptography to link between the chain. And we talked about smart contracts and how you can write complex programs using smart contracts and develop decentralized applications. And we talked about how the data, once entered into the blockchain, becomes tamper proof thanks to the cryptographic link that you create with each block. And we talked about third-party elimination that is done using smart contracts. So, just like the vending machine replaces the vendor, you can eliminate any and all kind of third parties using smart contracts. And we talked about cryptocurrencies, which was actually the first use case of blockchains. There are other use cases which we will deal with in coming webinars. So I think it's time for a bit of Q&A. So yeah, so there is a question. Smart contracts is essential. Yeah, basically the concept revolves around smart contracts. Like there are, like I said, there are various platforms. And so with Ethereum, they call this program smart contracts. There, like I said, there are various kinds of blockchains. There are various that goes by various names, and they have different names for smart contracts. Like there is a blockchain platform called Hyperledger Sawtooth, and it calls the smart contracts. Basically, the similar kind of programs are called transaction processes, and with Hyperledger Fabric, they are called chain codes. So basically, the fundamentals are the same. Each platforms have various name for various the same thing. Like smart contract. In Ethereum it is called you know in Ethereum it is called a smart contract, and in Hyperledger Fabric it is called a chain code. In Hyperledger Sawtooth it is called transaction processor. Different names, almost kind of same thing. So that's it. So you need some sort of something similar to a smart contract in order to create decentralized applications. So I think that answers your question. So if there is any questions, you can ask. It's yeah. I think yeah, we'll be attending to the questions now. So if you have any doubts, don't worry. Even if after even after the session, I have given mail, mail address in the description. You can mail your doubts to that mail, and we'll clarify those doubts. So, yeah, I think that answers the question. Like, a smart contract is essential for making a dApp. Can't we create dApps without smart contracts? The thing is, every blockchain platform uses some kind of programs. Smart contract is basically the name Ethereum gave to that particular, program. Yeah, the first one to verify the first Bitcoin transaction. Like, so uh, there's no it was done using a consensus, like when the first network popped up, there was not just a single person. When Satoshi actually collaborated with multiple person in bringing up different nodes, and they used something. There is a consensus. If you are willing to explore, I can't go into much details about it because it will take a session of its own. So Bitcoin uses a consensus called proof of work. So I think from the beginning itself, they used the consensus to verify this first Bitcoin transaction. So if you want to know about how the block is consented in the Bitcoin network, do check out proof of work, which is the consensus that Bitcoin uses. So there was like I said, Satoshi collaborated with different people in order to bring up the first network. So proof of work was basically the method that they used to verify and validate a block, the very first block in the Bitcoin network. So yeah, any other questions? So I think that's a wrap. I think we can. We can conclude this session. Now, I hope you got something. You understood the basic fundamentals of blockchain. I think all these given words here, you have a firm idea regarding all these words. If you have any doubts, if doubts persist, like I said, you can mail your doubts to our KBA mail, and we will get back to you. Yeah, okay. Okay, there is an I do transaction like money transfer. I don't find any issues doing it. Yeah, see, I'm not saying that bank in and itself is a faulty system. See, like I said, when I talked about the story of Bitcoin, uh, Satoshi introduced, like in 2008, there was an issue called the Great Recession, which led to the downfall of a lot of banks. And when you analyze that particular instance, or the Great Recession, you can see that the fault actually went to the government policies and as well as the management of the banks. So that's what led to the downfall, or that's what led to the Great Recession. So it was at that time that Satoshi introduced this new system. He just told that you can transfer. You don't always need a bank uh, to transfer cryptocurrencies. Sorry, you don't need a bank to transfer currency, or you can also have a parallel way. You can have a parallel or a different kind of currency that doesn't use a bank. I'm not saying that bank is faulty, or I'm not saying that it's a bad system. Actually, bank is quite a foolproof system. It has been here for as long as currency itself. But when it comes to management, yeah, okay. Like I said, it depends on your situation. There are times when you need to use blockchains, and then there are times you don't need to use a blockchain. Like, we talked about, one of the most major points that you have to refer if you want to check if you should use a blockchain is to see if you know if you are dealing with a process that requires n number of trusted third parties. If you want to simplify or disrupt a process that contains n number of third parties, then you can look into blockchain as a solution, and blockchain and smart contracts, or blockchain development as a solution. There are various criterions, like I said. You see, we talked about blockchains being a distributed ledger. So it has constraints regarding the amount of data that it can store. Like you cannot store an entire movie or film or music onto blockchain. What you do is you take transactional records and store it. So if your solution requires huge amount of data, then it's better that you don't stick with blockchain. So there are people are coming up with ways to sort of there are there are ways to address the scalability issue of blockchain. People are coming with solution. uh, yeah, so I think that answers. There are certain criterions that you should go through. I think we will address the development part of blockchain in another webinar, and I'll give you a slide that tells you how to see if your solution actually requires a blockchain. There is an amazing, I think there is a blog regarding this particular topic. So basically, you have to check if there is a third party involved, and if you're trying to make the system better by removing those third parties, or if you are creating an app that requires some sort of transactions or something like that, and does your app really require the information to be distributed or decentralized? So you have to go through all these criterions to make sure that your solution requires blockchain. Yeah, I think we should address this question in the coming webinars. Okay. Yes, there are countries that adopt blockchain technology. There are firms. I would say that all the major, you can look into any major. I'm not talking about countries. I'm talking about companies. You can look into IBM, Microsoft, Alibaba. All of them have built one or other sort of applications using blockchain. And there are countries that use, even Dubai, even in India, they have a lot of places like Telangana, and even in Kerala, we have people who are adopting blockchain to build applications and to, you know, and better the system. Yes, so there are countries and there are companies and there are institutions that use blockchain. So I think that's it. So, I don't think that I dealt with too much technical stuff in this webinar. I just raised the surface. I just gave a basic introduction to the fundamentals. So we will have subsequent seminars that deals with more and more complex concepts of blockchain. So I think that's it. So, most importantly, please stay safe, stay home, take care. See you in the next webinar. Thank you.